This video is running through reducing balance loans in the context of the Recursion and Financial Modelling unit for further mathematics. So a reducing balance loan is one where we are combining an aspect of growth and an aspect of decay. So if you remember from what we've looked at previously, growth is when we have a recurrence relation where something is being added on each time, whereas decay is when we're seeing that decreasing pattern. So if we look here, we've got an example of the value of a reducing balance loan, and you can see that overall it is decreasing. However, behind the scenes, what is occurring is that we've got growth occurring in the form of interest that the bank is charging. So at the end of one time period, the bank will charge a particular percentage of interest, and that forms a compound interest, so a geometric growth there. Then, in order to pay off the loan, we're making a periodic or a consistent payment, a constant value, which is greater than the interest that is being charged. And so the overall effect we can see here is that the new balance of the loan will be less than the previous balance. And so what we're seeing over time is that that payment, the full payment amount, is a constant value, but the interest that's being charged by the bank is actually decreasing each time because it's a percentage of the previous balance or what was currently owed. And so over time, we will end up seeing that the balance owed, it comes down to zero. So we're actually paying off the loan. And so in the context of further maths, when we're looking at reducing balance loans, we want to be able to represent these as a recurrence relation. We don't actually have a general rule that we use in further maths to represent this style of a recurrence relation. There is one that exists though. However, in further maths, we utilise the finance solver on our CAS calculator to help us with that general rule style. So just a quick recap of what the recurrence relation looks like. So remember, we will have that geometric style of growth. And so because we are talking about geometric growth, we have that R value, which is the multiplier, but it is 1 plus. And we're showing that as the rate divided by the compounding periods over 100. So adjusting that if it's paid monthly or quarterly or weekly. We also have this component here, the linear component, which is our regular payment that is being made. And so that is shown as a decrease because it is coming off the balance of the loan. An example of how we would take this information and put it into recurrence relation form. If Ahmed borrowed $12,000 to pay for a holiday, he will be charged interest at a rate of 6.12% per annum, compounding monthly. And this loan will be repaid with monthly repayments of $500. So if now we wanted to write that into recurrence relation form, we're taking those key components. So thinking about that we have the $12,000 as the initial value, or V0. We have an interest rate of 6.12, and that is compounding monthly. So we have compounding 12 times a year. And we have his repayment as $500. So that's our value of D. So now we want to put that together into a recurrence relation. Much like all of our other work with geometric style, the first thing we want to do is to calculate what is our capital R value. So we're doing 1 plus our interest rate divided by the number of compounds per year over 100. And that gives us an R value of 1.0051. And remembering we need to show growth, so we want it to be 1 point something. Putting that together now into a recurrence relation, make sure you do take note of what pronumeral they're using, so what letter they're using to represent this particular relationship, and using the same in your answers. So V0 is $12,000. Our next value will be R, so 1.0051 times the current value or balance, and minus our payment of $500. And so there's our recurrence relation. More often, we're actually asked to take an existing recurrence relation and be able to interpret different parts of it. So here we have Gloria takes out a loan of $200,000. She will make regular monthly repayments. The balance of the loan in dollars after n months, Bn, can be modelled by the recurrence relation. So we have B0 equals 200,000, our initial value, and Bn plus 1 equals 1.0035 times Bn minus 3,700. And so firstly, we're asked, what is the value of the monthly repayment that Gloria makes? And in this context, remember the constant amount that we are subtracting is our monthly repayment or our regular repayment. And so here we have $3,700 as the monthly repayment for Gloria. Part B, we're asked to show that the annual percentage compound interest rate for this loan is 4.2%. Now, when you see a question that says show that, you have to imagine or pretend you do not know the answer. So what working would you do with the information that you have to be able to find out that interest rate? And so at the moment, the only piece of information we have is this capital R value. So remembering that R is equal to 1 plus the rate over the compounds over 100, we can look at the information we have and see what I do know is that the capital R value is 1.0035. The other thing I know is that it is compounding monthly. So I've got monthly repayments, and so I'll be compounding the interest monthly as well. So that would be over 12 over 100. So the only thing I don't know at the moment is that interest rate. So I've created an equation, but now because they're asking me to show that the interest rate is such, I do have to actually do some working. And so from here, if I start to solve that equation, I'm going to start by subtracting 1 from both sides. That gives me 0.0035 and R over 12 over 100. The second step, if I think about if I'm going to multiply by 100 on both sides, I would have 0.35 equals R over 12. And then finally, I'm aiming to get R on its own. I would multiply 12 on both sides. And that would leave me 4.2 equals R. And so my rate is 4.2%. Now, depending on how many marks a question like that is worth, that will be your guide as to how many steps of that working you need to show. But at very, very least, the bare minimum, you need to be prepared to actually show a setup of an equation, okay, so that you can show the context of the values that you have. And then, if you can, you're wanting to manipulate from there. Amortisation tables is a small little add-on to the recurrence relation section of reducing balance loans. So what it means to amortize or amortize a loan is to actually pay off the debt. So we're making these regular repayments until the point that we have completely paid off the loan. So a table actually goes ahead and shows how that interest is being charged and the effect of the payment that you are making each time period. So thinking about that sort of graph I showed before, it's showing the numerical values of what's happening each time. So useful to remember that your regular payment that you are making, part of that is going towards cancelling out or paying the interest that the bank has just charged on the loan. And then the remaining amount is actually coming off the balance, and we call that balance reduction. So it's useful to remember that the interest charged plus the balance reduction is equal to that regular payment amount, because then you can use that information to help you fill some gaps. The amortisation tables have a couple of key features as well. So generally speaking, when we're talking about a loan, they are set up in this way. So across our headings, across the top of those columns, we generally list the payment number. Then we talk about the payment amount, the interest charged, the balance reduction, and then finally, what is the current balance of the loan for that payment. Some things that you can pick up from the table: your initial value or your principal will always be the balance at payment 0. The second thing is that our repayment amount will be listed under that column payment amount. Now, in most cases, that stays consistent throughout the entire loan. However, sometimes they do adjust that payment. So be careful that you are checking the information each time. Okay, so some pretty standard calculations that you may be asked to do include finding the interest that has been charged. So, for example, Jamie has a reducing balance loan and interest is calculated quarterly. And Jamie makes quarterly repayments of $10,000. The interest is charged at 9% per annum. We want to calculate the interest charged with payment 1. So we're being asked to fill in this section here. What is the interest on payment 1? And so to calculate our interest, we're taking the previous balance and multiplying that by the rate over the compounding periods over 100. So in this case, our previous balance was $50,000. We're going to multiply that by our rate of 9%. It's compounding quarterly, so over 4 and all over 100. So that gives us $1,125. So the interest being charged is $1,125. In the case of any values that are not correct to 2 decimal places, when you're filling out an amortisation table, you are actually rounding off because each of those is considered an answer. So in this case, not an issue, but if it wasn't a nice to 2 decimal place value, we would be rounding off. So the next value we could be asked to find is what is the principal reduction. So now that you've calculated the interest of $1,125, how much of that $10,000 payment goes towards reducing the principal? And so here we are making a payment of $10,000. $1,125 went towards paying the interest that was charged. And so that leaves us with $8,875. So that principal reduction, $8,875, is what we would actually be able to take off the balance of the loan. Okay, so that third and final step for our amortisation table is that finding the balance of the loan. And so each time we're taking the previous balance, so the one directly above, and then we're going to subtract the principal reduction that we've just identified, so 8875. And so for this loan, that means I can say that my new balance of the loan after the first payment will be $41,125. So a new example here. This is more common and a more common example of what you would see in an exam. So we have Samuel has a reducing balance loan, and the first 5 lines of the amortisation table for Samuel's loan are shown below. Using the values in the table, calculate the principal reduction associated with payment 3. So we want the principal or the balance reduction for payment 3. So we're after this little section here. And so note here, we don't know anything about the interest rate. We don't have any of the other information, but I actually don't need it because I need to remember that my payment amount is equal to the principal reduction plus the interest. So I can use that and say, well, my principal reduction will be my payment minus the interest charged. So in this case, I know my payment was $1,600. The interest that was charged was $956.15. So that means my reduction in this case is $643.85. The other thing I want to be able to check is if I'm on the right track. What we should be noticing with our interest is that each calculation or each row in the amortisation table, we should see the amount of interest being charged decreasing because it's a percentage of the previous balance, and that's also decreasing. At the same time, if our payments are staying consistent, then the principal reduction should be increasing slightly each time. So we go from 640 to 641.92 to 643.85. So we are following that pattern of increase there. Another example of what we may be asked to do with an amortisation table is to actually find, with a blank row in the table, find the balance at the end of that payment. So if we're calculating just with the table, there's a few steps of calculations required here. We this time have some more information to help us do that. We can see that our interest is calculated monthly and Samuel's making monthly repayments of $1,600. The other important thing is that the interest is being charged at 3.6% per annum. So if we want to find the balance after payment 4 is made, so this end value here, before we can do that, we firstly need to find what interest was charged, then what was the balance reduction, and then finally, what was the new balance of the loan. Okay, so just giving some more room here. And so firstly, we're going to find what was the interest. That will be our previous balance, so $318,074.23 multiplied by our rate of 3.6 over 12 for 12 compounds per year divided by 100. And so that gives us an interest charge of $954.22. The second step is to find our balance or our principal reduction. And so remember we said that would be our regular payment, so $1,600 minus the amount of interest that was charged. So $954.22 gives us a balance reduction $645.78. Finally, now we have enough information to find what was my my new balance, okay, or the current balance. And that will be the previous balance, so $318,074.23 minus the principal reduction, so $645.78, which gives us a final answer of $313,428.45. That gets us our final answer there. So a few steps required if we're doing it with an amortisation table. This is a type of question that we might choose to use technology for instead. And in the next video, we're going to look at how we use the finance solver. Okay, final example here, just another example of what you could be asked and how you can interpret what's going on in the table. So Yashen has a reducing balance loan. 6 lines of the amortisation table for Yashen's loan are shown below. The interest rate for Yashen's loan increased after one of the 6 repayments had been made. The first repayment made at the higher rate was repayment number what? So if my interest rate has increased, what I am expecting to see is that the amount of interest that I'm being asked to pay is not going in the same pattern as I expect. So I'm looking for, instead of it decreasing each time, has one of those interest payments increased in comparison to the previous one? And so if I have a look down the column here, I'm decreasing from 349 to 343, but then here for between payment 16 and 17, it's going up again before decreasing, decreasing, decreasing. So we're decreasing and then increasing out of pattern. So where the increase has occurred is after I have made my payments at the end of 16, we're seeing an increase in the interest rate. So that means that the first payment at the higher rate is payment number 17. Okay, that's it for an overview of reducing balance loans and amortisation tables. The next video will go through how to use Finance Solver to assist with these. Thanks.